In this video, we're going to talk about the sum relationship, which we saw in the previous video when we looked at the buttons. So this picture shows that some of the small buttons are also white buttons, right? Here, right in here are the small white buttons. So some of these small buttons are white buttons. The two circles overlap. So what that is the sum relationship, which is always shown with two overlapping circles. It means that there is something in the overlap. If there isn't going to be something in the overlap in an Euler diagram, we don't show them overlapping. So here it's true that cats and pets overlap, right? There is something in the intersection. It's not the empty set. These inside right here, these are pet cats, right? And over here, these are cats that are wild, that are not pets. And over here, these are other kinds of pets, like dogs. So if we want to use an Euler diagram to represent some animals have four legs, we have things with four legs because there's an overlap. Now, if there isn't an overlap, like there's no such thing as a cat-dog, no cats are dogs, then we represent them as not overlapping, as two separate diagrams. So how do you think you would use an Euler diagram to represent no fish are purple? And do you think it's true? Is it true that no fish are purple? Pause the video for a second and think, how would you draw no fish are purple with two circles? One circle is the fish circle, the other circle is the purple things circle. Okay, let's scroll up and see. You should have two non-overlapping circles because I said no fish are purple. Now, it's actually not true. There are purple fish. Really, we should have drawn these as two overlapping circles if we were thinking about real life. But in logical arguments, you're supposed to pretend that every statement you are given is true, without bringing in any outside knowledge like this picture of a purple fish. So if we're using Euler diagrams to test out whether a logic statement is valid, even if we know this statement is not true, no fish are purple, we still pretend it's true to test out whether our statement is valid or not. If you're using it in the classroom, if you're using it as an organizer or a mental map, then you want to show the true thing, obviously, right? So now let's try combining all of these ideas, all, some, and none, into one picture. So for this one, I do want you to pause the video for a second and see if you can put it together in one picture. All cats are furry. So remember our all statement from the previous video. Some cats are pets, and put them all together in one picture, which would be, let's see, a circle for cats, a circle for furry, and a circle for pets. So only 3 circles in your picture. Give it a try, pause the video, and see if you can do it. So hopefully you did pause the video, and here we go. We should have one of these two things. Definitely cats has to be inside furry to get all cats are furry. So either one of these has cats inside furry. And the thing is, without using outside knowledge, it's not clear to me whether or not we definitely have to say some cats are pets. So these two circles have to overlap. Some cats are pets, but it's not clear if pets is inside furry things or outside. I mean, if you use outside knowledge, that there are pets that are not furry, that the real picture is the one on the left. But since we don't know which picture actually is correct, we should draw both of them. And that's part of the idea behind Euler diagrams, is that you try to put all the possibilities down in your diagram. Venn diagrams are about, for sure, knowing exactly where each object is. Euler diagrams are about trying to test out what's possible. And just so you know, here's a furless cat, right? There are cats that are not furry. That's a sphinx. But anyway, you're not supposed to bring that in. So now let's see if you can try this one. All cats are furry. All furry things are cute. Some cute things are birds. So you're going to have, let's see, a circle for cats, a circle for furry things, a circle for cute things, and a circle for birds. So you have 4 circles to try. Pause the video a sec and give it a try. So there are actually a couple of answers for this one. It doesn't matter if you got both of them, but if you thought of one of them, that's the best. So these are our 2 possibilities. Actually, there's 3. We could even have birds and cats overlapping if we really didn't know that there's no such thing as a bird that's also a cat. Well, there are catbirds. But anyway, you should have something like this, right? You have to have cats inside furry. You have to have furry things inside cute things. And you have to have birds overlapping with cute things in some way, because the overlapping piece is the sum. There you go. So now we're going to look for our last piece of looking at Euler diagrams. We're going to look at sets of numbers, natural numbers, counting numbers, whole numbers. And I don't know if you know this, but natural numbers start at 1 and whole numbers start at 0. So actually natural numbers are inside of whole numbers. That means that all natural numbers are whole numbers. How about the square numbers, the Fibonacci numbers? How about integers? Do you know where integers are? How about rational numbers, irrational numbers, natural numbers? So this is the one more time to just stop the video and see if you can figure out where each of those things goes. So hopefully you did actually stop the video. Think about irrationals, think about rationals, think about the natural numbers. And here we go, here's the picture. So the irrationals are all out here all by themselves because these are the numbers you cannot write as fractions. And rationals you can write as fractions, right? So these 2 cannot overlap at all. There's no such thing as being able to write a number as a fraction and at the same time not being able to write it as a fraction. These are 2 separate circles. But inside of rationals is integers, because all the integers can be written as fractions. And all of it is inside of real numbers. The real numbers part is not really the most important thing here. The most important thing is really to understand that the whole numbers are inside of integers because there are more integers than there are whole numbers, right? And that the rationals, which includes whole numbers, fractions, and decimals, is the largest set of all. Notice that we've got some sum statements, and notice that we've got some, not some sum statements, some all statements going on here. All natural numbers are whole numbers. And we've got no integers are, where are the integers here? No integers are irrational because they don't, those 2 circles don't overlap. So that's the end of this video. See you in the last video.